Open the gas cylinder with the help of cylinder key. As CO2 is in liquid form, it passes through the heater and takes the form of gas. Depending on the size of the filler wire, the flow rate of CO2 gas is adjusted on the gas cylinder regulator to flow into the flow meter. The gas passes into the flow meter where the pressure of the gas is adjusted as per the heat requirement of the filler wire size for forming a shielded arc. Next, adjust the welding current and voltage by adjusting the knob on the welding machine according to the thickness of the materials to be welded or according to the welding position. The distance between the metal surface and the tip of the electrode is called arc length. Adjust the current and voltage individually. If the voltage is too low, the wire sticks to the base metal, generating cracking sounds, and no arc is produced. If the voltage is too high, the wire burns, arc length becomes long, and much spatter is generated. It is also very important to maintain normal arc length of the gun. The wire speed is also maintained depending upon the material or metal thickness. We will move on to do some welding. The first exercise: straight line beads on mild steel plate of 10 mm in flat position. Take the mild steel plate and mark the required dimensions. Hold it in a machine vise. Make sure the marked portion is held away from the edges of the fixed stud. Cut the workpiece to mark dimensions of 10 cm of 100 mm length using a hand saw or a power saw. Let us see the base metal preparation once again before we start to weld. Before starting the welding of ferrous or non-ferrous metal, it is very important to clean the edges and welding area from rust, dust or dirt, oil and grease if any. For cleaning severely corroded areas, grinding may be used. File the job piece properly with a flat file to smoothen the edges. Applying wet chalk on the job piece helps to see the marking better. Remove inflammable or unwanted materials around the welding area. First, fix a 0.8 mm diameter wire spool in position. Pull it through the roller guide to the contact tip of the torch or gun and lock it up. Wear safety apparels like apron, gloves, welding goggles, and welding screen when required. Switch on the welding machine. Turn on the CO2 gas heater as it takes about 5 to 10 minutes for the liquid CO2 to form gas. Before welding, check all the gas joints with soap water to see if there are any leakages in the joints. Check all the machine connections thoroughly and fix the earthing cable. By now, the CO2 gas is also ready. Set the arc voltage at 19 to 21 volts as required for dip transfer mode. The gas flow rate is set at 8 to 10 LPM. Set the feed rate so as to get 90 to 100 amps by striking the arc on a scrap plate. Set the workpiece in a flat position on the table. Hold the torch at an angle of 10 to 15 degrees to the punched line of the workpiece. Open the CO2 gas flow and electrode wire before striking the arc. Strike the arc. Maintain a filler wire stickout of 8 to 10 mm from the end of the contact tip to the job as required for dip transfer mode. Deposit the bead on the punched lines of the job from one end to the other. Weld full length of the workpiece by filling the material in the weld area, moving forward or backward. Here, backward method is being used. Allow it to cool in atmospheric temperature for 5 to 10 minutes. Wear chipping goggles to remove spatters and slag with the chipping hammer. Then, clean the joint using carbon steel wire brush. Check the welded surface for any defect. Let us go through this exercise one more time. Exercise 2. Fillet weld T and lap joint on mild steel plate of 10 mm thickness in flat position. Mark the required dimensions on the mild steel plate as you did before. Now, the workpiece is ready for welding. The welding machine is on. The carbon dioxide gas heater is also on. Arc voltage is set at 19 to 21 volts as required for dip transfer mode. Gas flow rate is 8 to 10 LPM. Mark the center of one plate. The center marked plate is used for the lap joint. Let this be C. Next, mark another plate. Let this be A. To make the base plate B for a T-joint, set plate B on the plate A in the form of inverted T perpendicular or 90 degrees to A as shown here. Feed rate is set to get 90 to 100 amps by striking the arc on a scrap metal. Tack weld on both ends of the T-joint. Set the plate C as a lap joint as shown here on the 75 mm wide plate with T-joint centered on it. Tack weld at both sides of the lap joint as shown here. Keep the tack welded job piece at 45 degrees from the horizontal plane so that the welding can be done in flat position. Deposit the bead on the tack welded job piece from one end to the other. Weld to full length of the workpiece by filling the material in the weld area, moving forward or backward. Let it cool at atmospheric temperature for 5 to 10 minutes. Then, fill the next joint. Remember, the angle between the T-plate and the gun should always be 45 degrees. The angle between the electrode tip and the base of gun direction should always be maintained between 10 to 15 degrees. Once the filling of the second joint is over, let it cool again. Now, deposit the bead again on the back side of the joint as well. Let it cool again. Remove spatters with chipping hammer. Clean the joint using carbon steel wire brush. Check the welded area for uniform flow of filler material. Inspect the welded joints for undercut, porosity, uneven bead formation, edge of the plate melting off, distortion if any, and good bead profile. Check the welded surfaces for cracks using destructive and non-destructive tests. Let us see this exercise one more time. Exercise 3. Fillet weld outside corner joint on mild steel plate of 10 mm in flat position. Prepare the mild steel and mark the dimensions. Cut it, file it, and clean the workpiece to be joined. Particularly the top of the plate, the side walls of the groove, and the underside of the joint. Once this is done, the job piece is ready for welding. The welding machine is on. The CO2 gas heater is switched on 5 to 10 minutes before starting the welding to form CO2 gas, as it is a liquid gas. With an arc voltage of 19 to 21 volts for dip transfer mode, the flow meter is fixed as 8 to 10 LPM. Set the feed rate. The same 0.8 mm diameter wire spool is used for welding. Tack weld on both the ends. Hold the gun perpendicular or 90 degrees to the joint and strike the arc at the tack, which is also 90 degrees. Move the torch from one end to the other end of the joint in flat position. Maintaining the angle of the torch at 10 to 15 degrees towards the direction of travel. Weld to full length of the workpiece by filling the material in the weld area, moving backward. Maintain a filler wire stick out of 8 to 10 mm from the end of the contact tip to the job as required for dip transfer mode. As seen in the earlier exercise, let it cool for 5 to 10 minutes. Remove spatters with chipping hammer and clean the joint using steel wire brush as done in the previous exercises. Check the welded area for uniform flow of filler material. Check the welded surfaces for cracks using destructive and non-destructive tests. Let us see this exercise once again. Exercise 4. Butt joint on mild steel plate of 10 mm in flat position. You have already seen the preparation of the jobs. Groove or file a 1.5 mm root face on each biveld as shown. Now, the workpiece is ready for welding. .8 mm diameter wire is used for welding. The procedure for CO2 flow into heater and the welding gun is same as observed earlier. Set the feed rate. The arc voltage is set at 19 to 21 volts as required for dip transfer mode. The gas flow rate is set at 8 to 10 LPM. Hold the gun perpendicular to the joint and strike the arc at the tack. Keep a gap between the joints, otherwise the job may get attached to the base. Open the CO2 gas flow in the gun before striking the arc. Strike the arc, maintain a filler wire stick out at 8 to 10 mm from the end of the contact tip as required for dip transfer mode. Maintain the angle of the torch at 10 to 15 degrees towards the direction of travel. The first deposit of the bead is called the root run. Weld to full length of the workpiece by filling the material in the weld area. Allow it to cool for 5 to 10 minutes and then check for uniform flow of filler material. Repeat the filling process one more time in the second run or the intermediate run. Don't forget, maintain a filler wire stick out of 8 to 10 mm from the end of the contact tip to the job as required for dip transfer mode. Deposit the bead weld to full length by filling the material in the weld area. Cool it and repeat the welding process for the final covering or third run. Remove the spatter as done earlier. Check the welded surface for cracks using destructive and non-destructive methods. Let us look over this exercise one more time. Exercise 5. Fillet weld T-joint on MS plate 10 mm horizontal position. Here, we have the plates made ready after cutting. Set the plate B on plate A in the form of an inverted T as shown here, which you have earlier seen also. Tack weld the two plates on either sides, keeping the T-joint in horizontal position. As seen earlier, for 0.8 mm wire, the arc voltage is set at 19 to 21 volts and the gas flow rate at 8 to 10 LPM. When the plates are ready, mount the plate such that the plate is vertical and the scribed lines are in horizontal position using the job positioner.